Normal distribution doesn't have to feel complicated. In this video, I'll guide you side by side through IB/AI Paper 2 questions using the GDC, explaining the exact thinking and mathematical ideas used in every step of the solution. Let's get started. So let's quickly take a look at the syllabus document. This is an extract taken from the SL 4.9, which is showing everything you need to know about the normal distribution curve, the properties of normal distribution, the diagrammatic representation, the normal probability calculations, which will be done using the GDC. Inverse normal calculations, this is also done using the GDC. And I want you to note this carefully. Students should be aware that approximately 68% of the data lies between 1 standard deviation from mean, 95% lies within 2 standard deviation from mean, and 99.7 of the data lies within 3 standard deviation from mean. So this is a good way to sketch a normal curve. Whenever you are sketching a normal curve, you can put the mean in the middle and 1 standard deviation above mean, like add 1 standard deviation and subtract 1 standard deviation, 2 standard deviation above mean and 2 standard deviation below mean, and 3 standard deviation above mean and 3 standard deviation below mean. So all of the data falls within this. The curve has to be symmetrical, like as far as you can make using. So this is something known as an empirical rule, though it's not written over here, but we call it empirical rule. So there is 68%, and then within this, there is like 95 point something. And then within 3 standard deviation, it's 99.7. So whenever the question demands you to sketch, you can use this idea to sketch your normal curve. So take out your GDCs, guys, and let's get started. A company produces electronic components on a large scale. They carry out quality control tests to determine whether the components meet the company's standards. Zakir, the owner of the company, wants the quality control team to analyze the distribution of the weights of the components. Okay, so it's a distribution and it is of weights. So it sounds like it's a continuous distribution. Nowhere does the question says yet that it's a normally distributed data, but still, remember that normal distribution works with continuous data. Based on historical data, the quality control team knows that the weights of components follow a normal distribution, right? With a mean of 2.5 grams and a standard deviation of a 0.15 grams. Part A. Find the probability that the weight of the component selected at random is greater than 2.8 grams. So first of all, in your solution, make sure you write X follows on normal distribution. Since the parameters are mean and standard deviation, your mean here is a 2.5 and your standard deviation is 0.15, right? So write your mean here, 2.5. And since we write variance over here, you can write 0.15 square, right? And now I would encourage you to make tiny diagrams. It always gives a good impression to the examiner that the student knows what he's doing, she's doing. Okay, so the mean comes in the middle, 2.5, and we are looking for more than 2.8. So for more than 2.8, it has to be here, this region, which we are looking for, right? Okay, so probability X greater than 2.8. Now we need to use our GDC. Take out your GDCs. Okay, so go to menu and second stats, go to distributions, select normal. And since it's an inequality, go for CD. Okay, choose variable. And here, what's your lower limit? Your lower limit is 2.8. Since normal curve is continuous and goes all the way up till infinity, for the upper limit, you need a very huge number. Some students just put like a 1 and like many zeros in front, but I usually like writing 1 into 10 raised to power 50. You can even try it with like write 1 and 0, 0, 0, 0 all the way, and you'll get a huge number, right? What is your standard deviation? It is 0.15. And what is your mean? It's a 2.5. All right, so let's execute. And here is our answer, 0.02275. 0.02275. You can give your final answer correct to three significant figure like 0.0228. The probability that the weight of a component selected at random is greater than W grams is 0.8. B1, show a diagram of a normal curve to show the area represented by this probability. So B1, we need to show like what's going on. Remember that probability X greater than W equals to 0.8. First of all, it represents an inverse normal situation. What's an inverse normal situation? When you have the probability, but you do not know what is the weight or what is that value which you're trying to get. So how do you sketch it? You can just show the mean in the middle, okay? And here we go, like this. I'm trying to make a better normal curve. Now observe, this is 2.5 and this area is a 0.5 and this area is a 0.5. In a normal distribution, the mean divides the bell curve into two equal halves. Since the sum of probability is always 1, so that's why the half of 1 is a 0.5 to the left, 0.5 to the right. Observe this carefully. Okay, so I know that W is going to be here somewhere. Reason being that this is a 0.5 and this is a 0.3 because this is a 0.8. So you can show this in your solution that this is the region. And how much area is represented over here? It's a 0.8. Let's take a look at like how can we find W using inverse normal. Now there are two possible ways. One is the direct way, like you can greater than W is a 0.8. So you can, let me just show you how you can find it using the graphing display calculator. Okay. So go to menu, again to two, distribution, and normal. So you see there is normal PD, normal CD, but now we use this INVN, the inverse normal button. Data is there. It's not the left, it's the right region, right? Okay. So let's go to the area. There's nothing here. Area here represents the probability. So put a 0.8 and my mean and standard deviation is already entered into the GDC correctly. Let's execute. So this is, W is going to be 2.3738, 2.3738. That is W. Now, what can be the alternate way of finding the same area? You can try this on your own. So if you choose the left, like X less than W, but then you will use the area as 0.2 and use your GDC to get the correct answer. So you can give your final answer correct to three significant figure. So that's going to be 2.37 for W. To pass test 1, the height of a component must be between 2.3 grams and 2.7 grams. So part C, 1. Find the probability that randomly selected component passes the test 1. In order to pass it, the weight of the component must be within 2.3 and 2.7. So put the 2.5 in the middle and make your bell curve and show it. Oh, it should look like a bit symmetrical. Show a 2.3 over here and a 2.7 over here. So this is equal area, like 0.2 to the left, 0.2 to the right. So we need to find this region. Always write the inequality, what you're trying to get, 2.3 and 2.7. This includes in the method marks, right? Okay, now let's use our GDC to calculate this region. Exit out Go to distribution, go to normal, go to CD since it's an inequality. This time the lower is a 2.3 and the upper is a 2.7. No infinite region this time. It's a finite bounded region between 2.3 and 2.7. And the rest of the data is correct. Let's execute. It's going to be 0.81758. 0.81758. Correct to three significant figure. It's going to be 0.818. Okay, part 2. Find the expected number of components in a box of 200 that will pass test 1. So since we need the expectation is the number into probability of success. So write 200 into 0.81758 and let's get this value. So I go to my normal part of the calculator and expectation, you can check the formula in the formula booklet. Expectation is NP, the number into probability. So this is 0.81758. So I'm getting 163.516, 163.516. You can give your answer as 163 or maybe 164, right? Zakir asks the quality control team to conduct a more in-depth analysis by performing a new test. Okay, so now we've got a new test, test 2. There was a test 1 before and now test 2. The probability of a component passing test 2 is this, 0.95. The team randomly selects one box and tests each of the 200 components. Okay? So now you need to recognize the binomial distribution. Now you might be thinking why this question jumped immediately into the binomial distribution. This is the problem with these structured paper 2 questions. Like you're solving a normal question, but your question might lead into the binomial distribution. You might be thinking why. There is a constant success probability. And you have fixed number of trials, which are 200 components, which you are testing. So this is now X follows a binomial distribution with an N 200 and the probability of success is 0.95. Remember the parameters of binomial distribution are N and P. N is the number of trials, P is the probability of success. Part D, find the probability that exactly 190 components pass the test. So D, I will use probability X equals to 190. This is exactly. So now, how do we solve this on the graphing display calculator? Go to menu, go to stats, go to distribution, but this time not normal. Instead, choose binomial distribution. And since it's equal to 190, so press PD. Go to variable. Now X, you will write 190. And number, like num trial, the numbers, that is how many components were tested? 200. What's the probability of success? It's 0.95, right? That's the probability of success. Let me just check my information. Oh yeah, that is correct. Okay. So let's execute and check. What do we get? This is 0.128357. 0.128357. You can give your final answer correct to three significant figure as 0.128. Okay? Part E. Find the probability that at least 188 components pass test 2. Now, this is something worth noting. How do you do the more region in a binomial distribution? Some of the newer calculators have this option. They can choose the right side or the left side in a binomial as well, but my Casio version doesn't do that. So I'm going to be teaching you, like, if you have at least 188 in binomial distribution, that's going to be, let's take the complements, since I can use the CD button, which is the left region, 1 minus probability X below 188. So what's the fixed value, the complete value below 188? So this is going to be 187. Watch out carefully. Since in a discrete distribution, there are exactly complete things. So below 188, the only value which comes is 187. So let's use binomial distribution again, but this time we need to get into the CD. Okay, so the number I'm going to put, what's the value? It's 187. So I put 187 in X. The components are still 200, and the probability of success is fixed. It's constant, 0.95. Let's get this. So this is 0.20352. 0.20352 subtracted from 1. Let's see, what do we get? So go out to the menu, 1. So 1 minus, oh, I forgot this, 0.20352. This is 0.20352. Yeah, am I right? Oh yeah. Just gotta be careful when you feed the values in the GDC, okay? So this is 0.79648. 0.79. Oh, I keep forgetting these values. 648. So what will be the answer in three significant figures? 0.796. There we go. Instead of testing all 200 components, Zakir now decides to test a random sample of 12 components from a box of 200 components. So previously he was testing 200 components, but now he's just choosing 12 of these components. He decides that the box will only be dispatched if at least 10 of the 12 components pass both test 1 and test 2. So now we need probabilities for both test 1 and test 2. That's why I took from the previous part. I copied it here. So you can see this was previously in the question. To pass test 1, the weight of the component must be within 2.3 and 2.7 grams. And I got that answer from the GDC. The probability of the component passing test 2 is already given, which is a 0.95. So let's call this probability of T1, test 1, which is 0.81757756. I'm using the unrounded one, and probability of passing the test 2 is 0.95. So they're saying the results of test 1 and test 2 are independent. Now, this is also very important. I'm putting a star over here. Check the independence formula in the formula booklet. Probability of A intersection, or you can say and B, is probability of A times probability of B for independent events. Do check this. You can pause the video and go back and check this formula. So if test 1 and test 2 are independent, it means the probability of passing both tests is just the product of their probabilities, 0.81757756 times the 0.95. I'm trying to get the success of this scenario, 0.81757755, and I don't want to miss any value. 6 into a 0.9 and 5. Let's go. It's 0.7766. Oh, let's copy it. It's too many numbers. So I can copy it, but you can, in your exam, you can just write these answers, right? Okay. So now X follows again a binomial distribution. N is 12, but the success is 0.776698682. Okay. Again, I would encourage, don't use rounded answers over here. Instead, use exact answers. So how will it be dispatched? If at least 10 pass, right? Test 1 and test 2. So again, we don't do the at least thing. We reverse it. Less than 10 is less than equal to 9 in a binomial distribution. So I go to my binomial. Let's go shift, stats 2, distribution, binomial, and CD. So in place of X, I put 9. And in the numbers, I put 12. And in the success, I should put this number 0.77669868 and 2. Okay, let's go. So that is 0.52258. 0.52258 038 and 1 minus the answer. Let's get this. And then I can round my final answer in the end. So you see, this can be a good something worth noting because I check during my class assessments. Sometimes my students they just round any way they like to, but that's not the case. Read the instruction on the first page of the exam. The inexact numerical values should be rounded correct to 3SF, but your calculations must have the exact numbers, right? So am I right? 522588038. Let's go. It's 0.47742. 0.47742. Approximately, you can give it 0.477. Let's quickly take a look at another question. So this one is from May 2021, paper 2, time zone 2. So it would be wise to solve these questions with me. You can pause the video, try the question on your own, and then you can come back and check my work. It is known that the weights of male Persian cats are normally distributed with mean 6.1 and variance 0.5 square. So this is given variance. X follows a normal distribution with mean, which is a 6.1, and variance is 0.5 square. Sometimes they give standard deviation instead of variance. So watch out. Then I square that value. Now you don't need to square since it's already a variance. Part A. Sketch a diagram showing the above information. So now you can see that no specific scenario is given. Like it's not given like something more than or less than or between. They just want you to sketch a normal curve. So now the way to sketch it properly is like you can put the mean in the middle. And remember the empirical rule thing, no? Which I shared earlier with you. So we know that within one standard deviation from mean, like mu plus sigma and mu minus sigma. So what's your standard deviation? That's a 0.5. If you add a 0.5 to 6.1, that's going to be 6.6. And if you subtract 6.1 minus a 0.5, it's going to be a 5.6, right? So 68% of the value fall here somewhere. So we know that it's going to look like this. When do you sketch it this way? Like when no specific region is given to, show the shaded part of the normal curve. You have to just sketch this information, this normal curve. Okay, 6.6 plus a 0.5 is going to be it's going to be a 7.1, right? And similarly, I'm going to subtract a 0.5 from 5.6. That's going to be a 5.1, right? You can use a calculator too. Don't do mental math like me, but 7.1 plus point, that's easy, 7.6. And this 5.1 minus, that's going to be a 4.6, right? So we know that our curve should end here somewhere. Don't attach it yet to the x-axis, like here somewhere, right? So we know that 68% fall within this range, 95% fall within this range, and 99 point something fall within 3 standard deviation from mean. Like what's the notation like exact? This is mu plus sigma, and mu minus sigma. This is mu plus 2 sigma, 2 standard deviations above mean and 2 standard deviations below mean. And you know, like, what's the next thing? You can just put these numbers. So that's a good way to sketch. Part B, find the proportion of male Persian cats weighing between 5.5 and 6.5. So we need to find the probability that weights X are within 5.5 and 6.5. So you can show this in the bell curve also. 6.1 is in the middle. So you are trying to find the region. This is a 0.4 to the right. And this one is 5.5, so it's 0.6. So a bit behind 5.5. I mean, you can just approximately make these curves. not very accurate. This shows like some understanding of the normal distribution. So now we use GDC to calculate our probability. So go to distribution, stats, normal distribution, and go for CD. This time, the lower is a 5.5. The upper limit is a 6.5. Is it a 6.5? Oh, yeah, that's a 6.5. And mean is, standard deviation is 0.5, and mean is a 6.1. 6.1. Okay, so always check your information when you type in that have you entered everything correctly. Let's execute. I'm getting 0.6730. Oh, that is too much. I just have a good way. I can copy this, right? Okay, so my answer will be this thing. 0.67307493, and I can give my answer three significant figure as 6, 7, and 3. A group of 80 male Persian cats are drawn from this population. Determine the expected number of cats in this group that have a weight of less than 5.3. So this is part C. X, probability X less than 5.3. We need this score. So we know that X follows a normal distribution. Mean is 6.1. And this is 0.5 squared. You can see from the earlier parts. So show a tiny normal curve. This is 6.1, and we need this region, 5.3 and below, right? Okay. So now we use our graphing calculator to get the score. Go to distribution, stats, normal, CD. The lower, we need just a huge number, a very tiny number, 1 into 10 raised to power 50. I can put this. And the upper value is 5.3. And rest of the information is correct. Let's just execute. And this is, I can copy it. That's a good way. So this is my answer for this part. Now remember, we need expectation. So expectation, the expected value is always number into the probability of success. So what's the probability of less than 5.3? That is 0.054799929. And I can just put this value in my calculator. So 80 times, oh, I need to put that value now, so what's this? 0.054, let's just write it over here so I can see it clearly in my GDC. Okay. So let's go. 0.5479929. So you see, again, I'm using a very unrounded answer. So what's the expected number? Let's get it. It's going to be 4.3839 something. So now I can put this. So it's a quite small number, 4.38. So let's give the answer 4.38, right? That's the expected number. Part D. It is found that 12 of the cats weigh more than X kg. Estimate the value of X. So we know that out of 80, 12 of them weigh more than X kg. So this is an inverse normal situation. You have the this is 6.1. You have the probability, but you do not know what is X. So let's just decide where this falls. Like, I mean, it's not compulsory, but I'm just trying to teach you how to judge where this falls. So this is going to be 0.5 square. So we know that it's 12 and more than, so it has to be somewhere here. It's a value which is more. So greater than X is only 12 out of 80. So it must be here somewhere, right? But right now, the question wasn't demanding to sketch the curve, but I mean, you can get questions like these. So how do we calculate this? We just go to inverse normal, distributions, normal, INVN. Okay, so this time we need to choose right. Area is going to be 12 out of 80. So you can even put fraction. The calculator will make it decimal itself. And rest of the information is correct. Let's just execute. And I'm getting the inverse normal value as this thing. Okay. So X should be 6.62 kg. Part E, 10 of the cats are chosen at random. Find the probability that exactly one of them weigh over 6.25. I encourage you all to be very careful and recognize the binomial situation. So, this is exactly a binomial situation. 10 of them are chosen, exactly one. So, what's the success now? That's the question. Where is the success? So, listen to this carefully. The success will be taken from the normal distribution, which we have already. The normal distribution with mean 6.1 and standard deviation 0.5. So, what's the success? The probability of success is weighing over 6.25. So, let's get this from the GDC and then we can use binomial distribution. So, I go to normal distribution to get this probability. So, this is prime CD, and the lower this time is a 6.25. And now I need a huge number because you see, they're saying more than 6.25. So 1 into 10 raised to power, that's 50. Okay. And rest is correct. So let's go. This is your success. Let's copy it. The probability of success. So it's a 4-mark question. Now listen to this carefully. So X follows a binomial distribution now, you can write, with number of trials is 10. And the probability of success, you can write this thing 382088857, right? And we need the probability that exactly one of them weighs over 6.25, right? So probability X equals to 1. And that's going to be, let's go to the graphing display calculator and get the answer stats. And distribution, binomial, and this is PD since it's an exact value. So in place of X, put a 1. In place of number, you can put a 10. In place of probability of success, now this is important. You need to put all these numbers 0.382088, 0.382088, and that's a 5.7. So, and let's execute, and that's going to be 0.05 something something. Let's copy it. That's a better way. Okay. So they're saying 10 of the cats are chosen at random. Find the probability exactly one of them weighs over this. So it's going to be 0.05 and 0.18. That should be my answer. Well, that's it for today. And you have noticed that these normal distribution paper 2 questions are quite lengthy, structured, and you need to be vigilant. Each part is connected. Sometimes you need information to do the last part. In order to do the last part, you need information from maybe the previous part or the first 2 parts and something. The more you practice, the better you will become at these questions. Keep visiting for more useful resources. Over and out.